Hello, so this is A level physics, and today we are going to continue with A level 9702 specimen paper 2022. We would continue with question number 19. So, the question number 19 says that the water flows from a lake into a turbine that is a distance of 90 meter. The mass flow rate is 2400 kg per minute. The turbine has an efficiency of 75%. What is the output power of the turbine? So over here we just need to apply the formula for efficiency, which is power output over power input into 100, which is equal to 75. We need to find the power output. We need the power input. So in order to get the power input, we can calculate energy over time by using the formula mgh over t. We have our mass over time in terms of seconds as 40 kg per second, and we can just substitute it in over here, mass over time into g into h. So that is mgh over t, which is 35.31 kilowatts. So the power input becomes 26.4 kilowatt, which is a. So the next question is question number 20. It says that a wire of diameter d and length l hangs vertically from a fixed point. The wire is extended by hanging a mass m. The Young modulus is E. The acceleration of E follows g. Which equation can be used to determine the extension of the wire? So the Young modulus is Fl over Ae, and the force is basically the weight, which is mg, and we can write the area as pi d square by 4. So pi d square by 4. So we can just make E the subject. Making E the subject would give us 4mgl over pi d square into Young modulus. So D is the appropriate answer. So question number 21 says that which shows the correct labeling distance displacement versus, we have displacement versus distance graphs. So in order to say, let's see, A, this is the amplitude, that's correct, and this is the wavelength, it's the distance axis, so displacement is correct, so A is the appropriate answer. So question number 22 says that a vehicle emits a sound of constant frequency Fs. The stationary observer hears the sound. The vehicles move towards the observer at constant speed. The observer hears the sound of constant frequency of the vehicle, then accelerates. When the vehicle accelerates, it is moving with an increased Vs. So increasing the Vs increases the decreases the denominator, which is V minus Vs. So this term decreases, so the F naught increases. So initially the F naught was increased, the observer here and then it travels at a higher steady speed, then it moves with steady speed, and then it decelerates. So when it would decelerate, the value of Vs would decrease, and as a result the denominator would increase. So when the denominator would increase, the observed frequency would decrease. So C is the appropriate answer. So question number 23 says that a car is traveling in a straight line at a speed of this. It passed through a stationary observer while sounding its horn. The frequency of the sound emitted by the horn is 400. The speed of the air is this. What is the change in frequency of the sound? So first we need to make it when it is moving towards, find the frequency, which is 439, and then moving away, find the frequency, which is 367, subtract them, so the answer would be C, 72 Hz. So question number 24 says that which list of the electromagnetic wave is an order of increasing frequency. That's a recall question, you need to realize that it's B. Question number 25 says that in a single loop the frequency is f. What would be the frequency for a double loop? For a single loop, it's lambda by 2 is equals to L, and the frequency is V over 2L. When there are two loops, there would be lambda by 2 by lambda by 2, so that would be lambda is equals to L, and V is equals to f lambda, so f is equals to V over L, so that's 2 times of the fundamental frequency, so that's 2f naught, or C, 2f. Question number 26 says that which statement gives a condition that enables diffraction to occur? So B is the appropriate answer. A wave is partially blocked by an obstacle, the rest are not correct. So question number 27 asks us to find the intensity maxima from the grating. For the intensity maxima, theta must be 90. We are given with the G, so we can find the D from it. The distance between the slits, which is 1 over 300 into 10 to the power minus 3. We are given with the wavelength. So n lambda is equal to d sine theta, and n becomes d sine theta over lambda. So sine theta would be 1, so this makes up 5. So it asks us to tell the total number of the intensity maxima. So 5 would be on one side, 5 would be on one side, and 1 would be in the middle. So 5 plus 5, 10 plus 1 is 11. So C is the appropriate answer. So question number 28 says to find the separation of the slits. We are given with the wavelength, we are given with the D, the distance between the double slit and the screen, and we are also given with the X, this fringe separation, but that is 4 times. So just divide it by 4 and you will get the fringe separation, which is 72 by 4 into 10 to the power minus 3, and plug it in the formula and your answer would be a 1.2 into 10 to the power negative 4. Question number 29 says that what represents current, so that is the charge flowing per unit time. Question number 30 says that what does I is equal to naive symbol represent, so B is the appropriate answer. That's a giveaway questions. Question number 31 asks us to find the rate of transfer of energy, which is power, which is 16. So what does from here power represents? Current into resistance, I square R represents power, so just make it up and D would be the appropriate answer. So question number 32 says that a coil contains n turns. It is wound on a diameter cylinder D. The copper wire has diameter D. The resistivity for copper is rho. The diameter D is much greater than D. What is the total resistance to the wire? So you need to understand that R is equals to rho L over A. So the length is the length of the wire which is wound on the cylinder. So that would be the circumference. So that would be 2 pi R, which is D by 2, and there are n turns, so n into 2 pi D by 2. So L would become n pi D. So n pi D is your length, and your area must be the area of the wire, which is pi D squared by 4, the diameter of the wire. So the resistance becomes 4 rho n pi D by pi D square. So this becomes R is equals to 4 rho n D over D square. So A is the appropriate answer. So question number 33 says to find the current in the load resistor. So V is equals to IR, 9 is equals to I, all resistors are in series, so that would become 5. So I becomes 9 over 5, which is 1.8 amperes. C is the appropriate answer. So question number 34 says that which statement is correct? The switch is open, so when switch S is closed, the potential difference across the battery falls because the EMF never falls, EMF remains the same. So this falls, so C is the appropriate answer. Internal resistance, the work is done. Question number 35, it says to find the value of R. So this is R, this becomes R by 2, and this becomes R by 3. So this in turn becomes in series 1.83 R equals 66 kilo ohms. So R becomes 36. So this is D. So in question number 36 says that an EMF with internal resistance is connected in parallel with a thermistor. So the thermistor, temperature of the thermistor is increased, so the resistance of the thermistor would decrease. So the terminal potential difference would decrease because the resistance of the thermistor has decreased. Question number 37 says that the light intensity of the LDR is decreased, so the resistance of the LDR would increase and the value of P would decrease. So B is the appropriate answer. Question number 38 says that first a beta negative is decayed, so there would be an addition of a proton number, and then an alpha is being, so there would be a reduction of 4 and 2 from the mass and charge number. B is the appropriate answer. So question number 39 says that what represents proton and neutron, so that's C. And question number 40 says that what is the charge of a top antiquark, so that is negative 2 by 3e. So that's it for this video. Do like and subscribe my channel for more videos, and to all the new viewers, please do subscribe my channel. Thank you.